Hello and welcome to this week's 1829 talk. You're very welcome. I am Professor Annie Tindley and it's my honour to be one of the trustees of the Natural History Society of Northumbria and to be introducing these 1829 series of talks to you. The 1829 talks highlight and celebrate the year of our foundation as a society, as one of the oldest and most honourable natural history societies in Britain. And the purpose of these talks is to allow a platform and showcase for the most exciting and cutting edge new research being undertaken by our early career researchers. So they're here really to share with us the latest findings in environmental research. As such, I hope you enjoy this week's talk. And I could urge you, if you can, to follow us on social media, Natural History Society of Northumbria, and enjoy the talk.
Hello to everyone watching this evening. Hopefully at least a few people have made it past the pun in the title. My name is Ray Kidd, and until just a few weeks ago I was a master's student at Newcastle University studying biodiversity conservation and ecosystem management. The last and the largest part of the master's was the dissertation paper, and that's what I'm going to talk about tonight. Now, I love trees. In general, I think we should have more trees, and I spend quite a bit of my free time doing volunteer planting work. So because of this, my paper was a response to an open call from the Northumberland National Park Authority to help out with answering this question. Where are the best locations to plant 10 new 20-hectare native woodlands in Northumberland National Park? This was a great opportunity, and the reason I have two parts of the question in bold is that ideally the answer should be scalable, so you can change the 10-20 hectares to other sizes of native woodland. And also ideally it should be generalisable to other locations, so you can apply the same method elsewhere outside of the park. It's a really interesting question because it doesn't have a single objectively correct answer. Woodlands mean different things to different people, so I needed an approach that would bring a lot of these different factors together. I used a technique from the field of multiple criteria decision making called multi-criteria evaluation. It lends itself really well to answering this kind of complex spatial problem. So the project's quite broad. I won't be going too deeply into any one specific here, but I hope to give an overview of the whole project from the beginning to the end. So that's identifying the constraints, identifying the factors to include in the MCE, scoring the factors, identifying the best planting locations, and then we'll also look at the key results and some of the potential applications. I think this is a nice example of where a systematic scientific approach can give you a solid outcome in a really complex situation. And I should just clarify here that I'm not employed by the Park Authority, so all the research and views here are my own. To give some quick context to tree cover in this country, a little bit of the history, the ancient wildwood that would have covered most of the country thousands of years ago has been completely removed by human action over the centuries, and we hit a historic low of 5% at the turn of the last century. This has now crept back up to about 13% tree cover, but this is still among the lowest in Europe, and only about 1/3 of this is native species. Most of the rest is non-native timber plantation. So where should we plant more? We're tackling a difficult question here, so it makes sense to start with an easier one. Where can we not plant native woodland? Well, we can't plant on our settlements, we can't plant on roads or rivers, we can't plant on important archaeological sites or on our power infrastructure. We can't plant above the tree line or in areas that are so exposed that trees won't grow. We can't plant on deep peat or on other priority habitats, and so on. Once we pull all these spatial data sets together, it rules out roughly half of the national park straight away. In this map, it's the red areas that are unsuitable for tree planting. A slightly trickier question to answer is where is all of the existing native woodland? That's all the places you don't have to plant because it's already done. There's no single authoritative source for this, but if you pull together data sets like the National Forest Inventory, Ancient Woodland Inventory, grants awarded for woodland creation, forestry and land management plans, and also use some aerial imagery, it's possible to construct a best guess for where all of our existing native woodland is. So that's the green areas in this map, approximately 4% of the park area. I think you might agree that 4% native tree cover is really low. That ecosystem has been almost entirely removed. And it's notable as well that this is broken up into more than 1,000 distinct fragments. This is a very heavily fragmented habitat. So now we can take the park area and subtract from it the areas you can't plant on, and also subtract the areas that are already native woodland. What we're left with is all the areas that are available for potential native woodland planting. For the purposes of modelling, that area is then divided up into 1 hectare, that's 100 by 100 metre, square cells. So we're left with 59,518 1 hectare cells that are available for native tree planting. Native woodlands listed as a priority habitat by the UK government, but my first question was why? Why does the government want more native woodland? Why does the National Park want more native woodland? So I started with a literature review looking at the local and national planning documents that refer to native woodland, and what they all have in common is that they're written in the language of natural capital. Natural capital is the physical stock of assets, that's the physical stuff that makes up an ecosystem, and it provides ecosystem services that are of benefit to people. So native woodland is an example of natural capital, and its value is determined by the services that it provides to us. We have to bring in a bit of economic theory here because woodland ecosystem services are what are called public goods. They provide for everyone in a way that's difficult to charge for. So left to its own devices, the market will not provide us with woodlands. I'll come back to this a little bit later on. And that led to literature review 2. What services does native woodland provide to us? So these would be the factors that we then use in the multi-criteria evaluation. There are a good 30 mentioned in the literature, but putting all the papers together gives you a big 5. Biodiversity, carbon storage, recreation, flood mitigation, and landscape character. Most of the value of our native woodland is coming from these 5 things. I should just note here that biodiversity is not strictly speaking an ecosystem service, but it's clearly important and it's treated as such here. Importantly, all of these 5 things vary in space. So for example, if you plant a tree on a field, it might store more carbon, but if you then plant the same tree on a peat bog, you might lose carbon. Or a wood next to a city would get more use for recreation than a woodland in the middle of nowhere. We need to work out where to plant native woodland that maximises these 5 ecosystem services, ideally all 5 of them. And this is actually quite a difficult problem because these 5 things are measured in very different ways. The units of carbon storage are very different to our ways of measuring biodiversity, for example. The use of a multi-criteria evaluation solves that problem. It's possible to create a scoring system for each of these 5 factors, which you can then combine across the entire park. And I'll talk a little bit about each of these 5 factors in turn. Starting with biodiversity, the key point is that bigger is better. Larger woodlands are better for biodiversity. They have permanent open areas inside them with edge habitats, and they can support both shade-loving and shade-intolerant species. So potential woodland areas were scored based on what was already there in the surrounding area. They were given high scores when they would contribute to enlarging woodlands. This gives good structural connectivity. That's the creation of large joined-up habitat patches. I also looked at functional connectivity. That's how easy it is for species to move between habitat patches. In terms of animals, the red squirrel is our local woodland specialist. So I modelled their range and awarded high scores to areas where new woodland would bridge obvious gaps or replace land that's currently difficult for squirrels to move across. In terms of plants, I also looked at connectivity for ancient woodland indicator species. That's plants that have very limited dispersal abilities, so they're currently pinned to our existing old woodland fragments. In this case, scores were awarded where new woodland would build outwards from existing ancient woodland, so it would allow the expansion of these species. Combining these factors gives you this map. The greener the area, the greater potential for biodiversity if you plant native woodland there. And because of the importance of habitat connectivity for biodiversity, the highest scoring areas are mostly building outwards from our existing woodland. This is all about expansion and enlargement. Moving on to carbon storage, climate change, which is mostly caused by our carbon emissions, is probably the single largest problem that our species is facing. As trees respire, they store carbon, and it's likely they'll have a major role to play in getting our atmospheric carbon down. Native woodland stores a lot of carbon, both in the standing timber and the woodland soil, and most land types, with the exceptions of things like peat bogs, will store more carbon if they're converted to native woodland. So I looked at the long-term equilibrium condition. That's how much carbon will be stored once a newly planted native woodland is grown to maturity, and then compared that to the carbon stored in the existing land type. The highest scores were then given to areas which store the most extra carbon as they become native woodland. So here's the map. Again, the darker the green, the higher the score, and the more potential carbon storage. The best areas here are mostly arable and grasslands. The third ecosystem service I looked at was recreational value. So here I looked at a balance between supply and demand. Demand's related to the distance to local population centres. This heat map shows potential visitor numbers based on census data of how many people live within a reasonable day tripping distance of any particular site. Basically, this is how many people may want to go there. And the ability of a potential new woodland to supply that demand is related to its accessibility. Are there car parks or bus stops nearby? Are there rights of way across it? Is it access land so we can freely explore it when we get there? And there are also mental health benefits from woodland recreation, so much so that there's a movement towards giving out green prescriptions to reduce blood pressure and stress. The Campaign to Protect Rural England were kind enough to provide their tranquility mapping data, and high scores were given to the most tranquil areas in the park. Again, all of these factors were put together to produce a map of recreational value on conversion to native woodland. The highest scoring dark green areas are generally within easy reach of people. We can drive or get public transport to them easily. They're very tranquil, and we are free to roam across them when we get there. There were two more ecosystem services that the literature suggested were important for valuing native woodland: flood mitigation and landscape character. These are both interesting cases that were actually dropped from the analysis, and I'll try to explain why. So starting with flood mitigation, there are plausible mechanisms by which woodlands might mitigate flooding. The canopy acts as an umbrella against rainfall, water evaporates from the leaves, and woodland soils seem to be better at holding water than most of the types of soil. But, and it's a big but, there's very little evidence for this actually working in practice at large scale. These mechanisms seem to be very quickly overwhelmed by heavy rainfall, and they've only been shown to make a detectable difference in quite small catchment areas. The national park's dominated by the watersheds of the Coquet, the North Tyne and the Reed. All of these have areas greater than 100 square kilometres inside the park, and flood mitigation effects from tree planting just haven't been seen at that scale. There's also a problem specific to our native broadleaf, and that's that they lose their leaves over the winter, and that's when we get our heaviest rainfall. The potential for flood mitigation benefits across the park is actually very limited, so this was dropped from the analysis. And the last ecosystem service is landscape character. To be honest, I have some issues with this concept. Landscape character is a description of the existing environment, so by definition it's a snapshot of the status quo. If anyone's looked at the state of nature reports, the status quo makes for fairly bleak reading. The UK is described as one of the most nature-depleted countries in the world, in which the loss of nature continues. If the status quo is undesirable, then the assumption that landscape character should be respected is quite problematic. A lot of UK biodiversity and ecosystem service policy is heavily based on the Lawton report from 2010, that was Making Space for Nature. That argued for a step change in our approach to conservation and the restoration of large-scale habitat networks. The key words there are step change. If you're setting landscape character as a special quality to be preserved, then you're effectively stuck with making small incremental changes. So landscape character may not be fully compatible with these modern conservation ideas. And in terms of the existing landscape character of the national park, the native woodland is mostly found on steep-sided burns and the sides of rivers. It's the areas that are difficult to get to, so they've been saved from the deforestation that's happened everywhere else. That's given us a landscape character that's usually described as open, but that doesn't sound so good if you rephrase that as deforested. I'm not convinced that landscape character is a particularly useful concept, or that our existing landscape is a good guide for the future. So landscape character was also dropped from the analysis. That left 3 ecosystem services that were being combined to give the potential for native woodland natural capital across the park. I'm glossing over the maths of this, but multi-criteria evaluation plugs in all these different factors to give a final score to each of the 1 hectare cells in the park. And there's a visual summary of this here. So we have structural and functional connectivity feeding into a biodiversity score. We have the potential additional carbon storage in woodland soils and vegetation, and also the supply and demand of recreation. These are all coming together to give final natural capital scores across the park. So that's a measure of how beneficial it would be to plant new native woodland at every available point in the park. This is a map of these scores, and again the green areas are given the greatest benefits. So now we have this map, we're able to go back to the original question. To identify the best planting areas, what we'd like to do is start with our map of available areas, so this shows a small piece of it, and put down native woodland cells on top. It's a little bit like dominoes. We're trying to put down 20 continuous squares to cover the highest possible values on the map. We're actually getting into a branch of mathematics which has the fantastic name of polyominoes, which is brilliant. It would be great if you could get a computer to crunch through all of these possible combinations to find the 10 best woodlands, but there are more than 5 billion ways of connecting 20 squares, and the number of ways that you fit these combinations into 59,000 cells is so ridiculously huge that it might take longer than the age of the universe to work through them all. A dissertation is typically shorter than the age of the universe, so there was a big problem here. Or at least there could have been a big problem here, but there was a way around it, because the scores on the map are very highly aggregated. They're very clumpy. There are high scoring regions clumped together and low scoring regions clumped together. So we can start with the highest scoring cells in the park, like this example in red, and then walk outwards from it to find the 20 highest scoring cells surrounding it. So this is now our best guess for native woodland number 1. We do this enough times and we have the answer to our question. And the map on the right shows the 10 best locations picked out. These are our 10 suggested planting locations. 3 of them are close to Rothbury in the watershed of the Coquet, and 7 are along the North Tyne close to Bellingham. So what does this all mean? There are a few points to make about these results that are important. The first is from statistical analysis of the data, showing that the locations identified as good sites score highly for all 3 components. They score highly for biodiversity, carbon storage, and recreational value. There's no trade-off occurring between these factors. It's possible to find sites that are strong in all 3, and that's a really good sign. All the 10 sites are building outwards from existing native and ancient woodland, so they score highly for biodiversity, and they're in locations that also score highly for carbon storage and recreation. So this gives us the really interesting conclusion that where we should create new native woodland is where we already have native woodland. And that also means that planting in this manner would preserve landscape character, but not for reasons of landscape character. It's not that we want to keep the look or the aesthetic of what's there, it's that we have to work with what we have left. Another key result is that it's possible to compare the scores in the areas picked out by the method against the scores you'd expect if you picked 20 hectares at random. And the scores are significantly higher in the targeted areas. So what that means is that spatial targeting delivers significantly greater natural capital benefits than random choice, or potentially than landowner choice. It gives you more biodiversity, better ecosystem services. So spatial targeting is important. It can give us woodlands that are better for wildlife, better for climate targets, and better to visit. So how could we use this going forwards? Well, the method that's been developed is scalable and it's generalizable. It can be used to identify planting areas of whatever size, and it could be applied elsewhere. I'm not suggesting it's definitive. Truthing would still be needed to look at the practical realities on the ground, but it could be very useful in planning. As I mentioned earlier, native woodland ecosystem services are public goods, so tree planting is usually subsidised or incentivised in the UK. Spatially targeting new native woodlands would be important because it would give better value to the taxpayer by providing better services. It would also be useful in results-based agri-environment schemes for woodlands because it would allow some prediction of these results before you actually do any planting. It could even be possible to directly link initial payments to predicted results. And that predictive power could also allow government or conservation organisations to actively approach landowners where planting on their land would be particularly beneficial. And lastly, by expanding the method to include other types of ecosystem, so grasslands and wetlands for example, I think it could be useful in the planning of landscape scale networks for nature regeneration. And just to end on a personal note, I hope to continue to be involved with restoration of our lost native woodland. That's about it from me. I hope you found the talk interesting, and I hope it's shown how a systematic approach can start to tackle a really difficult question that doesn't necessarily have a single correct answer. I'd just like to thank my project supervisor, Dr. Roy Sanderson, Abby Mansley, the National Park Authority, and also Graham Willis and Liz Williams for help with some really useful data sets. If anyone has any questions, please just get in touch via my LinkedIn, and for anyone looking for more specific information on the project, the full research paper is available there as well. Thank you for watching and enjoy the next talk.